Welcome back to Blueprints Academy. Today we are here with another topic on Spark optimization. So this video is actually the introduction of the series that I am planning to create on Spark optimization, the problems that you might be facing on a regular basis. These are very common problems that I'll be talking about and their mitigation strategies. This video is not gonna be on any of the problems yet. This video is just gonna serve as an introduction to the series and what you can expect from the series. And in this video we're gonna talk about mainly the basics of Spark, the Spark architecture, how the execution of the Spark job works, what happens in the backend, and all of the basic things that you should know before actually trying to understand the Spark in depth in order to optimize the optimize the code or the performance. So I assume you have a basic knowledge of Spark, and we're gonna just brush it up here in this video. I'll just explain at very high level how the Spark works and and what you can expect from a Spark application when you run it on local or on the cloud or wherever in general. So without any more delay, let's start this video. So as you can see on my screen, this is the very basic and very common Spark architecture, where you have a master node, you have a worker node, and on worker node you have core and task. So core gonna be based on the machine that you are using, and then the tasks are actually running within the core. So more core, which means the more tasks that can run in parallel and more work that you can do in parallel, right? So it's a typical cluster with 3 nodes, one master, 2 worker, and this is what we call a Spark cluster. We have something called cluster manager. It could be standalone when you are running it on local, or Yarn, or Mesos, or Kubernetes, or anything else. So there's a cluster manager which is managing the cluster, doing the resource allocation, making sure everything is in place, or the things which are needed by the master program to actually run your job. So there's a cluster manager running some managing the cluster, then you have master worker to do your task, and that is what we call a typical Spark architecture, right? Which is distributed, which is master and the slave architecture. So I think this is actually known by everyone, but just to brush up your brain in terms of what it looks like when we talk about Spark architecture or Spark cluster, this is what it is, right? Now you have the cluster created, or maybe you are running it on local, whatever it is. There is some program that is being written in Spark, right? So you write something in Python, Scala, Java, or R, and then you execute that particular code. So what happens in the backend? So how does Spark actually run your job and give you the output that you want, right? So if I go a bit deep down, it's the execution of a Spark program. So we have a code, of course, and then after you have a code, you have some jobs, and jobs can do their work in parallel, right? That's why they are job. And then each job gonna have stages, right? So usually stages are in sequential order. So to do a particular job, you need some set of stages, and then those stages needs to be executed one after another in order to perform a task. And then you have the task running on the each partition in parallel, right? So that's why whenever you run a Spark job, you see some jobs being created on the Spark UI, and then when you go inside the job, you see stages for the job, and then eventually you have the task running, right? So this is how actually Spark converts your layman language code into its own way of running the things on the cluster, right? So just to show you in practical what I just told you, we have this code in Scala. So it just we are creating the Spark session, then we read here, then we do a transformation, which is nothing but adding a column with the current timestamp, and then we write it down, right? So when I write this particular program and try to run it, what happens in the backend on Spark? So when I run this job, it's gonna create 2 jobs, and if you see, each job is having stages. So the job 0 is having a stage 1, I mean 1 stage, and then job 1 is having also one stage, but then if you see the tasks, they are 8 tasks, and here it's one task. So now you would be wondering why the Spark has created two jobs, right? So in Spark, usually when you read the data, the one job is actually to scan the data to identify the schema, which is in this case job 0. That's why you have one task which is just to identify the schema. Then we have job 2. Job 2 as in job 1 in number, and it has, if you see, 8 tasks, which means it is actually now reading the data. So one job is to identify the schema, second job is to read the data, and then you have tasks within that, right? So this is what I was trying to explain here, how your code is actually being executed on the cluster. So you have a code, then you have Spark jobs, and then jobs are having stages, and stages are eventually running the task for you, right? I hope it's all clear until now. So now you know the cluster, you know how to write the program, you know how it runs in the backend, right? Now let's also talk about very important important a concept in Spark, which is nothing but Spark's query plan. How actually what you have written, read, transform, write, is being executed on the cluster, right? So this is how your cluster manager gonna work for you. But then what actually gonna be executed is what is called the execution plan. Okay, so I guess you might have seen this execution plan in many different places before, but just to refresh your memory, we're going to talk about this plan again. So first thing first, we have a Spark code. So once we have a Spark code, we're going to run that Spark code, right? So what happens in the backend is that Spark code is converted into unresolved logical plan. So it's nothing but a tree-like structure of what needs to be done. Nothing is being checked here. So Spark gonna blindly trust what you have written. Once you have unresolved logical plan, Spark gonna create a resolved logical plan. Now this resolved logical plan is important because Spark now gonna analyze your code what you have written with the available metadata. So for example, you are asking Spark to fetch a column which does not exist in the metadata or in the table. So in this case, in this phase, you're gonna get the error. Spark gonna check, okay, you are asking me for transaction ID, for example, and transaction ID does not exist in the table which you are asking to take it from. So in this case, Spark gonna give you the error, which is nothing but the analysis exception that you might have seen many times. So this check of the metadata or the schema happens in this stage, and if everything works fine, Spark gonna say, okay, we have a resolved logical plan. Now, once we have the resolved logical plan, Spark gonna create optimized logical plan. And to create optimized logical plan, there is something which is being used by Spark and which is called Catalyst Optimizer. So Catalyst Optimizer is nothing but a piece of algorithm or piece of logic which is run by Spark in backend to actually optimize your logical plan. And it can do many things by its own, by assuming that these might be the optimized way to do the stuff that you want to do, right? So for example, you have a scenario where you can actually change your code to use push down predicate, and you did not write it explicitly on the code. So in this case, Spark will add push down predicate by itself in order to optimize your query, and then it will produce an optimized logical plan. Now, once you have the optimized logical plan, Spark gonna create physical plan. Now, physical plan is the actual plan that is gonna be executed on your data, right? But then there might be many different physical plans. So I I think I should create it like this. So there can be one physical plan, then there can be n number of physical plans. So there can be multiple physical plans, and then out of those multiple physical plan, the Spark gonna execute one physical plan, and then it decide which physical plan needs to be executed based on cost based optimizer CBO. So this is also a piece of logic or an algorithm running which is actually checking which physical plan is best to execute in terms of cost. In terms of cost, I mean which is optimized. So there are costs associated with each and every physical plan. So the lower the cost, the better the execution plan is based on Spark, and then Spark gonna pick that particular physical plan and execute it. Now after execution, you have your RDDs and you play with it in whatever way you want. So this is the whole flow how Spark actually translates your code into its own physical plan and gives you the result what is expected. I hope it's clear. Now if you want to see this in action, so this data is nothing but the same data that we read above. And if you want to know where what is generated by Spark, you can actually do something called query execution, data.query execution or data frame.query execution. And then if you see, it will give you parse logical plan. So this is the logical plan, and which is this unresolved logical plan. Then it has analyzed logical plan, which is nothing but the resolved logical plan, you can say. And then you have optimized logical plan, which is nothing but here after utilizing catalyst optimizer. And then you have the physical plan, which is nothing but this, which is actually the executed physical plan. So if you want to see everything, you can actually see everything here, like what Spark did in backend to actually do the work that was expected. So you can use this handy function from Spark to get this information. That is clear. Now we're going to talk about the series. So as I said before, this is going to be a series of lectures in the form of videos where we're going to talk about common Spark problems. So now you know what is the Spark architecture, how you run your job, what is being done by Spark in backend, how your job is actually executed, how your tasks are actually executed. So now we can actually go deep into the problems that we face on day-to-day basis, which are mostly very common in all of the big data jobs, and we're gonna deal with them one after another. So again, iterating that each video after this one gonna be on one problem. What is the problem and what are its possible mitigation strategies? So the problems that we're gonna discuss in the subsequent series are the following. So we're going to talk about skew problem, we're going to talk about spill, we're going to talk about shuffle, we're going to talk about serialization, and also about storage and IO operations. So these all problems are based on my experience, what I have faced in my past 7 years of working, more than actually 7 years of working with big data and Spark in general. So we're going to talk about all of these problem and try to understand how we can identify these problems, because identification of this problem is also very important, right? And also sometimes we get confused or get lost walking through the Spark UI, right? So we don't know where to see and what to see and what metrics actually are important for us to know in order to optimize our jobs, right? So we're going to talk about all of these things in the respective videos of these problems. And probably we're gonna also work on how we can mitigate those problems. So that's all I wanted to tell you all. I hope you get an idea what you can expect from the series, what you can expect from the channel in general. And yes, so with this, I would like to say thank you for watching this video, and please stay tuned for the next videos that gonna be in line with this series. The first one, which we're gonna talk about, gonna be on SQ, and we're gonna talk about deep with SQ. We're gonna have some examples of showing you the problem and then the solutions that you can potentially use to fix the problem. So stay tuned and keep watching the Data Blueprints Academy. Until then, see you and have a good day. Bye bye.